So we're going to talk about the first and second translation theorems when referring to the Laplace transforms and inverse Laplace transforms. And here's the first. We'll just state the first translation theorem. It says that the Laplace transform of e raised to the at times f of t, which is some just arbitrary function of t, is equal to capital F of s, which is the Laplace transform of f of t, evaluated at s minus a. So, for example, this is Laplace of f of t, which would be f of s, and then everywhere we see an s in big F of s, we would plug in s minus a to get big F of s minus a. And we write form 1 here because we're going from the Laplace transform, we're going from the t domain to the s domain. And it's also helpful to realize that these translation theorems are, you can use the inverse, right? You can say the inverse Laplace transform of big F of s minus a is equal to e raised to the at times f of t. This is what I'll refer to as form 2. All right. So actually, we'll talk about the second translation theorem in another video, but let's go ahead and look at the first translation theorem, how to apply it. So in this first example, we're given find the Laplace of e raised to the 5t times cosine of 3t. Well, first of all, we always want to, when we're dealing with something that looks like this, right, where we have some functions that are being multiplied by each other, we know we can't use a table for sure. We know that this wouldn't be something that we could do the partial fraction expansion because we don't, there's no fractions here. We're going to want to look at using one of the translation theorems, whether it's the first or the second translation theorem. And you always want to have these, handy because you can always compare your problem to these problems and see which form you can use. So if we look at this problem, we see that we have e raised to the 5t, right, and cosine of 3t. And if we compare that to the first translation theorem, form 1, we see that e raised to the at in our case, a is 5, and f of t is the function of t, which is the cosine of 3t. And so the Laplace transform, we're given it's equal to big F of s minus a. So the work involves to find, first of all, what big F of s is. And big F of s is, well, it's just the Laplace transform of f of t, which we said is cosine of 3t. So the Laplace transform of cosine of 3t is, using the table, we can just quickly determine it's s over s squared plus 9. And then in step 3, we're going to so that's big F of s. But our answer to the problem is it needs to be big F of s minus a. So that means wherever we see an s in f of s, we're going to plug in instead s minus a. And in our case, a is 5. So if we notice this is a final solution here in this box, we're going to have s minus 5. Remember, an s used to be on the top by itself. And then here we have s minus 5 squared plus 9. Remember, it was just an s squared. So we've replaced every s with an s minus 5. And that's the essence of using the first translation theorem, form 1.